many of you hopefully are familiar with the Floridan aquifer system, which is one of the most productive aquifer systems in the world, and it underlies the entirety of the state. So this graphic I'm showing you doesn't represent the distribution of all of these aquifers. It simply shows which aquifer systems are utilized as drinking water sources. So way out here in the Panhandle, we use what's called a superficial aquifer that's locally called the sand and gravel aquifer. But for you guys, you also use a superficial aquifer system, much like parts of South Florida that use the Biscayne aquifer. So now you know a little bit about the geology of our underlying aquifer systems. And because of that geology, and typically it's because of karst, Florida's groundwater in our aquifers is vulnerable to contamination. We at the Florida Geological Survey have developed a GIS model called the Florida Aquifer Vulnerability Assessment, and it uses multiple layers to help show us where areas are on the land surface that a particular aquifer system, and in this instance, we're talking about the superficial aquifer system. And when you run the model, it puts out a map like this that shows you where the most vulnerable areas are within our state for each particular aquifer system. So the red areas here show where the superficial aquifer system is most vulnerable to contamination. And you can see quite a bit of the area in and around the Indian River Watershed, Indian River Lagoon. Much of this area is vulnerable, and it's vulnerable because of the underlying geology. So let's talk a little bit about the underlying geology. As I noted earlier, the Big Bend portion of the state, this is where most of the oldest limestone units are exposed at the surface. And as you might imagine, the older the limestone is, the longer it has had to undergo this process that we call dissolution, which enhances the porosity and makes for many, many more karst features than in areas like the Indian River Lagoon watershed. The superficial sediments here are very young. However, they are still comprised of limestone. So many of you are familiar with the Anastasia Formation, the coquina that it's commonly referred to. It occurs in and along here. But we also have a thickness of material that looks like this. So these are shells, obviously marine seashells, mixed with quartz sand, occasionally a little bit of clay. But each of these seashells are also susceptible to being dissolved away by the acidic water we talked about earlier and enhancing the porosity. Now, there's not enough of it in here such that if you dissolve it, you're going to have huge sinkholes. And additionally, it's not old enough to have undergone that process long enough to develop these. But still, there's enhanced permeability and porosity in here when this material slowly gets dissolved away over time, which it does. And here are some exposures of the Anastasia Formation coquina. So you'd asked me to give you sort of an overview about nutrient transport in groundwater, and I've sort of touched on a bunch of things that ultimately can help you understand that, it's not just nutrients, but anything that gets into our groundwater can move rapidly once it gets into the ground. And in particular, in these red areas, this is where the water in that superficial aquifer system is most vulnerable to contamination. So what about the distribution of septic tanks in this area? Well, you can see all of these blue dots represent septic tanks. I want to say there's somewhere on the order of 50,000 on-site septic tanks in this area. And, another issue with putting septic tanks in an area is the proximity to the water table. And as you know, there by rule, you have to have a certain height between the bottom of your drain field and the underlying water table. But when you live in a coastal region, not only do you have tidal influences to worry about, you've also got storm surges, and we are also obviously having to worry about the threat of sea level rise. So all of these septic tanks in the coastal zone here have the potential to contaminate groundwater. So, as I already alluded to, and, it's not just nutrients, but really anything that could be a contaminant that gets onto the ground surface can make its way into the underlying aquifer system and travel rapidly. Florida's karst aquifers, as we already discussed, allow groundwater to move incredibly quickly just due to the porosity and permeability. The superficial aquifer system in this area also moves and contributes water to the Indian River Lagoon, as you already probably know. The superficial aquifer in this area is comprised of Anastasia Formation coquina, which is limestone, as well as quartz sand and fossil shells, and it is also highly porous and highly permeable. And as a result of this geology, the superficial aquifer system in this area and in areas is highly vulnerable to contamination.